Hello everyone, this is Mohsen Siraj. I'm Senior Ansys Application Engineer working in Ozen Engineering. This is the second part of the second video that we have about geometry-based mesh adaptation. In this part, I'm going to show you how to set up this geometry mesh adaptation along with the previous mesh adaptation that we had for boundary layer and for gradient of the pressure. Okay, before starting to talk about geometry-based mesh adaptation, just a review what we found from part 1. For initial mesh, according to the best practice for mesh adaptations for Ansys Fluent meshing, initial mesh should shouldn't be too coarse. Either way, to not really represent correctly the geometrical features, for example the curved boundary that we have, sharp corners, and on the other side also it should have sufficient numbers of the cells that can really capture the physics of the problem and main characteristics of the flow field. For example, in the video one that I talked about the pressure drop, we saw that how coarse mesh could over predict the pressure drop. So be sure that to start with a good enough quality of the mesh, not only the minimum orthogonality, also about these two features regarding to the good representation of the geometrical features and also for the essential characteristics of the fellow field. So far in the first part, I've already covered this path of the solution that we talked about the mesh adaptations and also comparison with manual adaptation of the of an initial mesh. Now I want to move in this path that I want to talk about the geometry mesh adaptation. For la 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 la. Before starting, it is very important to know that we need a profile for auxiliary geometry that we use it as just like an envelope on the locations or maybe for the whole domain where we want to have the mesh adaptation based on the geometry. So we use a surface mesh that I created from the volume mesh. Okay, that I use it for creation of volume mesh and use this surface mesh for auxiliary geometry that we have. So this is one part, and another part it is the volume mesh that we will go to perform the uh, mesh adaptations for boundary layer and pressure gradient and also geometry based mesh adaptation, all of them on this volume mesh. One important thing before I start is that if you look at here at the units for creating the surface mesh should be the same units that we're creating the volume mesh, the fluent meshing. So be careful about this here that we need to have the match between the units for surface mesh and the volume mesh. Let's start here for the surface mesh. La 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 la. Okay, this I just use a local mesh. Okay, that it is for this face, as you can see, and the surface mesh should be much more refined than the volume mesh. This is very important. As you can see that previously I had 6 segmentation here for the initial mesh, and then I increase it to 9 or 10 partitions around these curved boundaries, curved edge for a refined mesh. But here you can see that I have much more. 1 2 3 4 5 6 7 8 9 10. I think it is above 20 to 20 segments for that. Same here for this part. So for part that I have curvature, curved boundaries, and also sharp corners, I have to be sure that the surface mesh could have basically has very good resolution to capture the curvature and what's happening for the geometry. So I prepare the geometry for the surface. La 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 la. So I prepare the surface mesh. I need to save it. One thing that I hear is important, that we need to first of all have this format for the mesh type. It should be legacy mesh file, and here instead of H5 I just use GZ to it means it is the way for zipping the file in Fluent. So be sure that we have it here, and then I save it somewhere that I can read it. Okay, so this is the surface mesh that I have. This is the surface mesh that I already created. Close surface meshing, and go for volume meshing for the domain. La 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 la. Bah, bah, bah. If you check the mesh quality, minimum orthogonality, it is 0.27, which is good, and number of the cells, it is 5900, pretty close to what we had before. It was 2700, 2800, now it is 2900. So if I want to show the mesh, you can see it. Okay, I have 1 2 3 4 5 6 7 8 9 10 11. Almost it is like a refined mesh that I had it before. I can have a little bit less uh, refined that, but we already learned that la 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 la. This is the mesh on the curved part at the uh, sharp corners. We already learned that if it is only 5 or 6 cells, okay, it is coarse mesh. And but this one it is, I think, 9 or 10. And also here you can see that the good mesh here. But again, the total number of cells, it is just less than 6000 as I had it before. Let's go for the setup. The fellow start with Fluent. So let's define auxiliary definition, new. Instead of primitive for the type, use surface mesh. click on surface meshes, read. Okay, I have to go, I guess, here for, yeah, that's one. This one here, it is, as you see, GZ file. And be careful that units should be millimeter, because I created the mesh by millimeter, not meter. Read it, close, and now you can see the walls. When I want to use this auxiliary geometry, use it for the define. I call it face for the faces. Click OK. You can see that I've created here another new one for another wall. I call it corner. Okay. So I define these two auxiliary geometries, and remember that because I had I have these two ball zones, so I define one auxiliary geometry for each of these wall zone. Also uh, I can show you. You can see that these are here, and for the corner also I can show you where it is. You can see that. Always check this auxiliary geometry. Be sure that they already fit the outer boundaries of your domain. So we're done for this part, and now we can go for use them for mesh adaptation. Either I can start from automatic mesh adaptation or come to the domain for manual mesh adaptation. So wherever I use, I have to go to adaptation control, general adaptation controls, show advanced controls. Here you click for reconstruct geometry and manage. So as you can see, I have only wall zones here, and this is for auxiliary definition. I use corners because this is for the that wall zone, and for another wall zone faces I use auxiliary geometry face. So we're done for these parts. Let's say that 500,000 maximum cell count, and say OK. So we're done for adaptation control. I need to define the boundary, one cell register for the boundaries and another cell register for pressure gradient, and use them to for the mesh adaptation for the refinement criterion here. Let's start with boundary. Two cells. You can here again group them based on cells, so you know that where you have wall zones, these two, and la 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 la. Name is boundary. Name is boundary. Save and display. You can see that where it is. It is it is other boundary of the or wall zones of the domain. Close, and I can use this here for the for and I can use this for refinement. Copy to mesh adaptation, automatic mesh adaptation, call it boundary. and every 50 iterations. Okay, you can see that now I have one here. I can create the second one. I can create the second mesh adaptation based on pressure gradient new. If I go to use the predefined criteria, you can see that I don't have it here. Okay, that I can use it for pressure gradient. The new feed variable is grayed out. Why? Because I haven't initialized the model. Initialize that and back to cell register new. Now it is available. Field variable is available to you. Pressure gradient. Be sure that to choose gradient. You know that I know what is the max mean. So in this time I say that whatever more than 30 for the pressure of gradient, go for the refinement. I call this feed variable register for gradient pressure. Okay, if I show that, say that save and display, see that there is nothing there, zero cell marked. This is because I haven't started the solution. So create that and use it for definition of this second mesh adaptation every 50 iterations and say okay. Now you can see the second one for pressure gradient here. So we're done for set up the mesh adaptation, and if you check one of them, go to general control for the adaptation, you can see that the reconstruction of the geometry is here, and I have these two geometry based adaptations for the wall zones that I have. The rest is for the same as before that I solve it. If I come here for the inlet, velocity inlet 1 meter per second, and let's also check the mesh. Okay, we can check the mesh quality here. You can see that almost it is 0.27, which is above 0.15, which is acceptable. Uh, Acceptable mesh quality regarding to the minimum orthogonality. And if I want to check the number of the cells, it is, you can see that 2576. Let's display that with the edges. You can see that 1 2 3 4 5 6 cells or partitions on this curved boundary. Same here for the inlet and also other curved part for the outlet that we have it. And for the mainstream of the fellow on this sharp corner, it is just only 3 cells, as you can see. And these are the boundary layer that we have. So this is the mesh. Let's create a plane similar to before. It is a YZ plane. If I rotate that, I can move it by cursor until getting to almost the okay, not bad. Here also I can change it, say that this guy, or maybe say that 7.5. Okay, say that, okay, create that, and I can see the mesh on this plane, and if I want to show this on better color, it is 1 2 3 1 2 3 for the mainstream of the cells, 1 2 3 cells, and 1 2 3 4 5 6 segment for this curved or curved boundaries, and you can see these sharp corners of that. So let's see what's happen if I run it. And before running, remember that we already have two reports, one for the pressure drop, another for cell count. Here for this one now I can see that how the cell numbers change during the solution. Okay, let's start. Residuals, cell count, you see that it is increased to 9. Okay, it is set to 90,000. Let's change the residuals to, okay, to 1e minus 5, all of them. To see more mesh adaptation. We see another jump in the number of cells, now is about 200,000. Another one, not too much increase in the number of the cells. We back to you. Okay, we're done for the solution. Residuals, these are each of these jumps shows that the mesh adaptation in the domain. The latest adaptation is this. Okay, let's look at that, the mesh. You can see that how geometry based adaptation really create a curved boundary between the initial nodes. And if we look at the everything's, say that faces together, but remove this one. You can see that here now I have very good curvature. You can see that here I have very good curvature, and here on that, but somewhere you say it is still bumpy. So it shows that even with this one there we have to be careful about the resolution. And here for the inlet you can see that this is because the initial mesh is not very good, doesn't have the good quality that we applied this mesh adaptation. You can see that here. This is for the inlet. You can see that what's happening. Like a bumpy what's happening to the inlet. And it could be similarly for the outlet. Look at the outlet. These are initial nodes. For example, this segment it is quite large in the initial mesh, and it wanted to create another nodes to produce the curvature from the background mesh, from the surface mesh, from auxiliary geometry. That's why it created the mesh like this. You can see that how many uh, inflation layers added here. But again, what's important here is that if I check okay, I change it. I just a little bit move this plane, and now back to the this plane. You can see that this is the one that we had it before. Okay, but this one you can see that it is like a bumpy that we have. These are initial nodes, and this ones it tries to reconstruct the circular curvature that we have here between the initial nodes. Not only added nodes here, but I really use the surface mesh like the background from auxiliary geometry to reconstruct the profile of that. You can see that. So hopefully you learn that and you learn about this method. And one more thing is that I could reduce the total number of the cell counts on this in this application in this example if I work on this gradient of the pressure, and instead of having only above 5, I just focus for example on the sharp corners that I have very high values of the of the pressures of the pressure gradients at there. Let's then say that for example I don't know 500 instead of 5 or whatever, then the total number of the cells will be decreased. Remember that if we really have a geometry that has many sharp corners and everywhere it is like a complicated geometry, if we want to manually refine the mesh, then the number of the mesh exponentially increase. And it is really hard to have partitioning in different parts of the domain that could really have a good refinement for the mesh. It takes time, but instead of that, we can use this geometry based mesh adaptation, specifically using the background mesh from the surface mesh of the same geometry, and use it toward the geometry based mesh adaptation that reconstruct correctly the curved boundaries of the geometry. So the main idea is that we can use mesh adaptation started from a good enough mesh, and satisfying the minimum requirement for the orthogonality is not adequate, is not enough to show that it is a good initial mesh. We have to think about the geometrical features such as sharp corners, such as curved boundaries, and also the main features of the flow field. If the initial mesh is a good representative of these features, then we can start to build up the mesh adaptation based on that. So in this video we started with the initial mesh that it is on the left, and as you can see that although we are showing some of the curvature of the curved boundaries here, but we see bumps and corners of the at the initial nodes there, and not enough really adequate number of the cell counts for the mainstream of the flow. If we use and rely only the criteria that are available in Ansys Fluent for mesh adaptations based on the solutions, refining the solutions, for example, on the gradient based criteria, this is what we got. That we refined also the boundary layer at the wall and the mainstream flow. As you can see how many more cells I have here compared to the initial mesh, but still I don't get the results for the pressure drop that I expected. So this is what I showed you in the first part of the video. In the second part, I showed you how to build up and set up the uh, geometry based mesh adaptation by using the auxiliary geometry. And now you can see that between initial nodes I have added nodes in a way that really reconstruct or resemble somehow the original geometry at the, for example, here at the curvature that I have here, at the curved boundaries that I have here. Previously I may have more initial meshes here or initial nodes here, but still I'm seeing these corners there. Here I can see that we not only added nodes, also position them in a way that resemble or reconstruct the geometry in a way that to match the original geometry. So this is very important, and it could gives us a much better resolution for the geometry. So we have to look at the critical locations regions, not only based on the gradients of the parameters like if pressure, velocity, or other parameters of interest. Also we look at the geometrical features. If the geometry is complicated, has many curved boundaries, corners, these are some things that tell us that we need to use the geometry based adaptations. If not, even we may worsen the mesh instead of improving the mesh quality. So hopefully you can learn how to set up this model and what to do with that. And one more thing is that if we want to work with the manual refinement for complicated geometry, because in this example it is very simple geometry, but in reality and in industrial applications the geometries are not such a simple geometry. So we need really time and efforts to have a good quality for the mesh after manual refinement. It is doable, but needs really cost in the expenses of time and efforts, and not necessarily means that we have a good mesh. Sometimes we may have over refinement and some areas that we don't need that. The good point in this mesh adaptation with geometry based adaptation is that we can have better matching between uh, the resulted mesh with the geometry, original geometry shapes, and also improve the mesh in the critical regions that these are somewhere that we are interested to check the physics of the problem, specifically some characteristics for like a pressure drop or gradient of the velocity or whatsoever, or even some levels of the turbulency there, so we can have a good quality. So we're done for this video. Thank you very much for watching this video, and don't forget to watch video for part 1 that shows that about how to prepare the model for mesh adaptation and comparison with original mesh, initial mesh for mesh adaptation without geometry based adaptation. Thank you very much.